Welcome back from the short commercial break. I guess it was a good lunch. This afternoon, I'm going to talk about how to organize and develop a more sustainable and environmentally friendly ASM site. The most important keys here are sustainability and environmentally friendly. Now, the question is, when the geologists or the geo guys have discovered that we have all the opposite, what comes to mind in the first instance? From our natural tendency, a typical miner will just jump and say, let me go and start digging. But hey, both of us know, all of us know that the gut feeling of operating an ASM mine had resulted in a lot of challenges, which include the environmental impact that we've seen around and has resulted in the ban from the current administration. Now the question is, can we mine more sustainable and environmentally friendly manner? Yes, I believe we can do that. So this afternoon, I'm going to show you how we can, from scientific point of view, not from art, from scientific point of view, how we can design and organize an ASM site. Often it's been an art, but can we introduce science? And that is why I'm here. And thanks be to God, we have experienced people around here who is going to help me in delivering this message. All right. Now we have Mr. Godwin Aran and Senior Yima. They are true miners, so please validate my point and let's make this one a rich presentation. Okay. All right. My presentation, my mode of presentation will start from the overview of what mine development process is through to manpower requirement. And the focus here is sustainability and environmentally friendly system. Now, I said that we need to move away from gut feelings of operating an ASM site to more careful design approach of organizing this operation. So the main objective is, at the end of the day, we need to be able to be empowered with the skills needed to design a typical mining site that is more sustainable and environmentally friendly. So there will be suggestion of manpower requirement to ensure that we achieve sustainability and environmentally friendly process. So the question is, what is mine development? Basically, it is a process. It is a process of making decisions in such a way that we could mine the ore of interest, or that we get a mineral of interest at profit. At the same time, we find a way to make it more sustainable and environmentally friendly. You get your money, but you preserve the environment. And that is the message. Get the money, you preserve the environment, and also the social impact we have on the environment. So the entire process of mine development process, as John quotes, stated that from stepping on a stone to opening and closing of a mine. So it's from the conception of a mine through the birth and the death of a mine. And even after the death, probably we will celebrate a year as we do in Ghana in terms of funeral, right? So that's what we're going to do. Now, the mining development process could include preparation of the mine site by clearing trees and blasting of rocks. Could also be construction of mining facilities to support the activities, and also creation of infrastructure such as power and kind of putting measures in place to transport this, or if we are to move from one point of process to the other. So basically all these activities, they are distinct in their own way, and they all pose one or two challenges to the environment if care is not taken. When you put all these distinct steps together, we call it a mine development process. And I said it's a process, it's an ongoing process. Now, when we look at the diagram here, a schematic diagram, this is a typical process flow sheet, or the life cycle of a mine. So mine development process could be referred as the life cycle of a mine. From the exploration to the distribution, that is when we saw the end product. Now, as my colleague Riley did, the exploration guys or the geology guys will provide us with the shape, the geological information that we need to make decisions. Now, when we get all these decisions with certain analysis to establish the feasibility of the project, the next question is, when do I start? How do I want to start it? and what sort of mining method would I use to get the best out of what I have. So today's focus will be on the development, where in this case we're looking at mine planning. How do we plan the mine before we even start it? We'll look at the factors used in pit designs. We'll look at the mine ventilation. We'll look at equipment requirement and mining methods. So today that presentation will be on this sector. Now, what is mine planning? The underlying word here is a decision-making process. It is a conscious effort to design your project before you start. So you think about the end product before you start. Like a good designer, you always have to make a decision. You always have to think about it before you take a first step. And until you are certain that the steps that I'm taking will not have negative impact on the environment and the communities available, then we say that yes, you have a good mine planning and design measures in place. In a typical mine planning and designing, we have several factors that are taken into consideration. Okay. Now, this is what we want. We want to, in mine planning, we want to get our product, but in more safer way, but not this one, as you see an accident occurring. So in order to get this one without getting this one, requires that we make a conscious effort to make decision. That is mine planning. Getting your product, but not resulting in death, as we could see over there. So there are key factors we often consider in planning of a mine. One is the natural or the geological factors, and this includes the geological conditions, the ore types, the grade, out to the metallurgical properties, including the hardness of the rocks that we need to process. The other one is economic factors. Assuming you have all the geological information at hand and you cannot mine profitably, because that is what drives the mine. Investors will want to see returns on their money. Now, if we don't have things of this nature, the economics not met, we cannot mine safely. So economic factors are also taken into consideration. The other one is technological factors. In terms of technological factors, assuming we want to use a pit, a mine pit. Now the pit should go, we need to have certain dimensions that will make the process or the work very safe for each and everyone to work. Hence we have the technological, so from the pit slope to bench dimension to ventilation, how we introduce fresh air to make the place very conducive for people. Now, often in books you see these three factors, but there's another factor that has become issue of these days, and that factor is environmental impact factor. Now you cannot confidently design a mine without taking environmental issues into consideration. Without environmental issues, investors will not invest. People are saying that we have certain certification, that the fair mine trade certification, and the concern is where do we get the gold from, or where do we get the product, the mineral of interest from. If they are not doing it from an environmental point of view, we will not buy. So assuming you start mining and people are not buying because you don't comply with your environmental requirement, nothing happens, so we cannot mine. So it's a key factor that we take into consideration in proper planning and design of a mine. Now, as part of the mine planning, we have a stage called the mine exploitation. Basically, this is a stage whereby we need to find ways to get access to the mineral of interest or the ore. How do we get access to it? Is it by scraping the surface of the earth? By getting the rocks out of it? By crushing? All these phases are called the mine exploitation. So generally, getting the material from the natural state to a state where additional processing techniques could be applied. And in typical mining, we have categorized these mining methods into two groups. We have the surface mining and the underground mining. Often we use the surface mining when your ore of interest is not far from the earth's surface. So assuming we have, let's assume this is a profile of a deposit. And assuming you have your mineral of interest just around this corner, it is easy to go by surface mining. But when it is deep, surface mining becomes difficult. So you need to introduce other mining methods called the underground mining method. So above about 15 meters, you think of going underground. So these are some of the underground mining methods and surface mining methods that are used in large-scale mining. But these methods could also be used in the ASM. That is why it was brought here. look at the ones with the Terrace, the open pit mining is being done. Quarrying is one of the ways we use in ASM. We have the open cast strip mining. I will talk much about these ones as I go on. Then we have the room and the pillar mining, which are also used in the ASM. Then the dredging, which is also is being used, but it's a big issue now because it is difficult to control some of the impact it has on the environment, especially on our water bodies. Now, because Ghana, we know much about ASGM, that is the artisanal gold mining industry. There are certain methods that could actually be used in the ASGM sector, and that has been outlined over here with the various ore types as described by our geology man. So when you look at the surface mine, alluvia, and colluvia material, which my colleagues here are very familiar with, we use the open cast or strip mining. We have the weathered lows, which terrace mining. We have the shallow pit, goes through to add this shaft opening. And sometimes the old tailings, people could also mine it, but those ones that are chemically treated, we don't advise that we go into that because it will be difficult to manage them. All right. So now let's go into the various methods and see the ones that are applicable in the ASM, the ones that are being practiced now, and what can be done to improve these existing methods. Right. Now the strip mining method. The strip mining method is considered as one of the surface mining methods. Now we often use this method when your ore body or mineral of interest is not far from the air. So assuming I have the entire section here as my land. This is actually the first projection, this is the plan. So let's propose, assuming I have a land of this size, with my ore reserve being estimated and I know confident that I can mine. Now, what I want to do is that because I have environmental impact issues into consideration, in the forward moving, what we look for, we think about reclamation of the land as a part of the entire journey. So what I do is that we section the land or the concession into several panels. So assuming this is the first panel, you get the vegetation and the topsoil, and what we call the overburden. Overburdens are often called the unwanted material. They are waste. They don't sometimes may contain traces of this mineral of interest, but not at economic value. So we get the vegetation, we get the topsoil, we get the overburden. We just chuck them somewhere in a safe place, that because we will also use it for subsequent reclamation. Now, when we start mining here, when mining is completed over here, we move to other panel. Now what happens is that the same tailings or the raw material or the waste material that is obtained from here, after going through a process which my professor will talk about, we can use that to first fill this pit. We move forward. Now after filling with the rocks and the other tailing material, we can now bring the overburdens of this section, including the topsoil, to backfill the hole over here. So in so doing, we have kind of a progressive reclamation, because when you ask the miner to go after mining to come back to reclaim, probably it will take the entire military of the world to force them back. But if measures are put in place, progressive reclamation could be done, and using a typical method like this. So as you move forward, you backfill. As you move forward, you backfill. Now we got to the last one. Now you've used this one to fill this one. What happens to this one? Don't forget that you have one chunk somewhere that you could reintroduce to this side. You fill it up, then your mining, you've gotten your money, at the same time you've reclaimed the land in concurrent manner without wasting much time. So this is a typical strip mining method that we use in the surface mine. Now we have the terrace mining. It works the same like the strip mining. They are common methods, but with this one, instead of with the other one, we have overburden. The mineral of interest are often associated with the material, loose material. But with this one, we have weathered materials. However, the weathered material, so sometimes we need a little bit of blasting and stuff to get the materials of interest. So, however, we go through the same procedure, whereby when you finish first panel, you go to the second, you use the second panel to fill the first panel in that order. So there is this concurrent money getting and reclamation process ongoing. We have the shallow open pit. Now, the shallow open pit, as you can see, the ore body is almost at the surface of the earth. It's just at the surface of the earth. And often when you go to some of these sites, these are some of the ways that we mine them. And I believe we can see this could be dangerous, assuming all these things are loose and you have water coming in. This will collapse. And from a source, I learned this thing had killed some people in the system before. So, can it be done in a more safer manner? Yes, it can be done. As if we introduce the benching system, if we mine in benches, it could be done and make it more sustainable. So, in terms of, so this is the benching system we're talking about. And this is being practiced in the large-scale mining. Now, other small-scale mining industry people are also using the benching system. In so doing, if there is any loose material that falls from here, it will not get to the man over here easily. It will be on the bench here. Then from here, it gets here. So before it gets down there, probably the people have already escaped. And it's on the other issue too is that at that point, you can monitor the stability of your benches. This one, you cannot measure the stability, but this one, when you come and you see loose material at the bottom of each bench, it is easy to tell that my bench is loose or my pit is loose. The stability has been compromised, so it probably will pose danger to people working around them, and you get off from there. All right. Now, in terms of mentioning about pit. Now, there are a lot of factors that comes to play in pit optimization or pit design. We just can't go there and start digging, because I have been told that yes, I can use strip mining, I can use shallow open pit. The pit comes with dimensions, which needs to be taken into consideration, and we have these factors. Now, among these factors, there are 2 or 3 of them that are key, determines the rest of the factors. One is the cutoff grade. The cutoff grade talks about the amount of mineral of interest in the ore, because before you carry out all these things, if your cutoff grade doesn't pay for the workers, doesn't pay for the employees, and even the pit, design of the pit, you don't go for it. The other one is the strip ratio. How much of the material, the waste material, assuming we have this profile, these are overburdened, that is called the waste. The question is, how much of this material should I get off before I access the rare ore? If it is too much, and economics will not permit you to do that, it is not viable to go into. However, in certain situations, the small-scale miner will still try at least, even if he gets a blade. Can you help me with the weight of a blade?
10 blades is a pound.
Okay, 10 blade is a pound. So the person will risk for just a blade or 10 blade or just a pound of it, and that survives for the day or for the week. Right. So the person will go for it. The other thing we look at is also the bench dimensions and the pit slopes. Now the bench dimensions is, we're talking about the height at which the bench should slide, the angle at which the bench should be. Now all these things influence the stability of the bench. And in a typical practice, it's being said that if you are using a dozer or if you are using a loader, the height of the bench should not be more than the height at which the loader could stretch, right? So if the loader could go this far, that is how the maximum height you could go. So these are some of the practical ways we can measure the height of the benches that we need to employ in the system. Now the underground mine. This is a typical ASM underground, and this is how they enter the underground working. See, there is a gentleman over here. This man is also here. There's another one here, and this man thinks this is a big pillar, so he's supporting the entire edge from not collapsing. Yes, it's worked for some time, but we can't continue to do this because today might be your lucky time, tomorrow might not be, if proper measures are not put in place. Okay. So, what are some of the proposed methods or what the improved ways of doing stuff? Now we have what we call the underground adit way of mining. Basically, I have my ore body here. I have my ore body here. We have hill covering my ore body. How do I get access to this ore body? Now, saying that we we go the lateral means where we create a path through the hill, then we dig around to get our all of interest. The thing is that we create passage for both humans, air, and other moving materials. How to transport the material out of the ground. But in previous slides, you could see that they don't create such mechanisms, right? Even if they do, it is not sufficient to sustain, to provide safer environment. So when you go through this process of having a well-designed pit or having a well-designed adit where we have proper ventilation, circulating, natural ventilation, even without having artificial ventilation, we could still have a safer environment. And this is a typical view of it, where people can walk in and out of it. But the other one, you need to crawl on the floor to enter a typical adit or to enter a typical workings. Now we have the vertical shaft, where that one also depending the shape of the ore body, we sink vertical shaft. That is workings where people could enter material for transport in there. It is also one of the efficient ways that has been practiced by the large scale mining, and we believe that. And I think the small scale mining, when you go to certain site, they are practicing it, and it's working more efficient way. And these are some of the things that we encourage that they practice. And as you can see, this is a typical ASM guy introducing his channel, his pathway to the underground. They have some pillars around them with timbers going in there, and they think it's safe. But when you go to some of the mine, they also work around old pillars. They work around old pillars and old adit or shafts that have been created by the large scale mines and abandoned one. They work in those areas. When you have them around, sometimes they are also safe to work in. But the challenge is that some people will go for the pillars that people have left behind to support them. They will start chopping the pillars. Some of the ASM guys will just chop the pillars and leave there, even there, instead of chasing the rare ore. Right. Now the question is, how do I choose when to use a surface mining method or underground mining method? There are certain requirements that we need to meet aside the economic factor, because one is considered to be expensive, right? So aside the economic factors, we have some key factors as has been outlined here: the size, the shape, the depth of the deposit runs through to the environmental impact during and after the mining. Some of the things, and including the safety issues around. Because if you cannot mine safely, there is no need for you to mine. And that is the key message we need to take home. We need to mine and mine safely. So these are some of the factors we consider in selecting a typical mining method. Now, after designing your mining methods, selecting your mining method, the other thing we need not to forget is what happened to my waste? What happened after mining? What happened after digging the pit? That is where the reclamation comes in. And I believe I have talked about the reclamation from there. Basically, it's the process of restoring the land as has been mined to a natural, economical, usable state. So, it though occurs once after the mining has finished, but we believe that this needs to be planned ahead, and it needs to be a progressive one instead of waiting for us to finish the activities. The other thing is that because it's sometimes difficult to ensure that good work is done, we suggest that reclamation standing committees should be established at the various districts if we don't have, to ensure that the miners are able to successfully carry out their reclamation. So the general process might be the overburden material and tailing should be used directly to fill the mined out areas. There is no need for you to probably go and get material from there if what you've mined out has been kept in a safer manner or has not been used. Then you can fill back the pit with what you already have. To promote, and also to promote natural vegetation, we suggest that yes, we need to cover them with the topsoil. So gathering of topsoil is also a key thing. It's not about you just scrapping the material, but you need to be able to differentiate between the topsoil and the overburden. If you get the topsoil aside and before the overburden, then the topsoil will encourage or promote the natural vegetation from growing. The other thing is that when we even fill that, some of the pits, we might not completely fill them out. So what do? We need to warn the public about it, if you can. put some measures in place to push people away from going there. Now, we cannot do all this mine planning and design without proper manpower. It's one of the key things. It's been a challenge for long. The ASM we see today is today because the so-called technocrat, the so-called skilled people are not involved. And sorry to say that, we leave it out to the unskilled who operate with gut feelings. Now, thank God that we have people who are also high learned people, or let me put it, the skilled people who are also involved. But we need to properly structure the manpower requirement in order to ensure that proper mining design and planning is done. So, saying that moving forward from gut feeling operation to sustainable, environmental friendly ASM operation, skilled labor needs to be engaged. And this is a typical just assumption that could be taken into consideration. We have a site manager, and I believe my ASM people will be familiar with these things. Can we have a typical mining engineer on site? Can we have a minerals engineer? Now, what are the rules? The mining engineer will help in the pit designs, in access to the ore underground. There's the role of the mining engineer. Can we have minerals engineer who will optimize your recovery process so that you get more gold, you get more of the mineral of interest that you want? We have environmental and safety engineer or officer around who ensures that the reclamation is done and done well, who ensures that you meet the EPA requirements and other requirements that you want. Then we have our general foreman there, where we have equipment operators and man workers. And I believe that when we are able to put in place proper manpower in place, I think the ASM sector should be good to go. The other thing I want to end here is that the ASM sector should not always be seen as a negative sector, because it has the power to create wealth, it has the power to transform communities. And we should rather see it as more of livelihood than distractors of our environment. All right, thank you very much.